Hello viewers, welcome back to the course on scientific computing using MATLAB. So, in the last lecture we have started with the method of undeterminate coefficient. So, we will continue with that one. So, today we are going to discuss the method of undeterminate coefficients. So, in this case we have, as we discussed in the last lecture also. So, when the nodal values or nodes, I can say that when the nodes are known, that is nodes are this one x0, x1 up to xn, the value of this one. So, when the nodes are known, then the corresponding method is called Newton-Cotes method. But when the nodes are also to be determined, then the method is called Gaussian, then the method is called Gaussian integration methods. So, in this case, this value, when the values of these nodes are known to us, then we will call it the Newton-Cotes methods, otherwise it is called the Gaussian integration methods. So, let us do one example that how we can deal with the method of undeterminate coefficient. So, let us take the example 1. Determine the coefficient A, B, C and the error for, so this is the formula given to us. From minus h to h, I have the function f(x) dx, and suppose this is given to me as A f value plus B value the function at 0, C the value of the function at h. So, in this case, if you see that we have some domain, so that this domain is my 0, this is my minus h and this is h. So, I want to do the integration, some function is defined to me in this case. So, in this case I want to do the integration. So, what I do, it is given to me that this is the coefficient A, B, C that is not known to me here, and this is multiply the value of the function f at minus h, value of the function at 0 and the value of the function at h. So, in this case we want to find the value of A, B, C. Now, I do not know what is the value of the function here, but I need here. So, here we need to find 3 coefficients, that is A, B and C. So, this is the method of undeterminate coefficient. We do not know what is the value of A, B, C and we want to find out. So, this is, I take it as equation number 1. Now, I need to find 3 coefficient. So, whenever I need to find 3 coefficients, we consider that that the method gives exact solution for all the functions, all the polynomials I should write of degree less than equal to 2. So, in this case I will consider that my f(x) is constant. So, that is I could call it 1, then it is x, then it is x square. So, in this case I have the polynomial degree, that is 0, 1 and 2. So, let us start doing that, how we can find out. So, for now in this case we are considering that now we consider the function f(x) is equal to x raised to power r, and r I will apply 0, 1 and 2. So, that we have already discussed. Now, from minus h to h I take r is equal to, so for r is equal to 0, the first one I take. So, this is will be x raised to power 0, that is 1 into dx. So, from here if I take this one, then it is just a integration from minus h to h dx, and this will be equal to 2h. It is given to me that this is equal to a f of minus h plus b f of 0 plus c f of h. Now, what is the meaning of f of minus h? So, let us discuss this one. What is the f of minus h? But I know that the value of the function f(x) is just 1 for any value of x. So, it means that this is equal to 1 also. F of 0 is also 1, f of h is also 1. So, from here I can write that this is equal to a plus b plus c, just this value will be. So, from here I can write that first equation will be a plus b plus c, that equal to 2h. So, I call it equation number 2. Then for r is equal to 1, my function f(x) will be just the x. Now, from the left hand side, minus h to h x dx. So, it is a odd function and I am multiplying from minus h to h. So, I know that this value will be 0. So, it is just this value, and on the right hand side I will get a. What will the value of f minus h? It means I am putting x is equal to minus h. So, the value of the function will be minus h. F of 0, that will be 0, f of h, that will be h. So, from here I can write that this is equal to a into minus h plus b into 0 plus c into h. So, from here I can write that this is equal to minus ah plus ch. So, this value is, and that is equal to 0. So, this is equal to 0. So, from here I can write that this is my next equation. Now, for r is equal to 2, my function f(x) become x square. Then, if I multiply by putting the value of x square dx, then in that case I will get, so this will be x cube by 3 minus h to h. So, it will be 1 by 3, and this will be h cube minus of minus h cube. So, it will be 2 h cube by 3. So, this is the value I am getting after solving the integration. Now, on the right hand side I will get now a f minus h plus b of f 0 plus c of f h. So, this one I need to find out. Now, from here this is equal to a and f minus h, because f x is x square now. So, this will be minus h square plus b, this will be 0 square plus c, and this will be h square. So, from here I can write that this is equal to a plus c h square. Now, from here I can write that this will be equal to a h square plus c h square, and that is equal to, what the value we got, 2 h cube by 3. So, this is equal to 2 h cube by 3. So, that is the value. This is my equation number 4. So, I call it equation number 4. Now, suppose I have 3 variables, this a, b, c, and the 3 equation that is we have now. So, from on solving equations 2, 3 and 4. So, this one we can solve by the methods we have applied for solving system of equations. So, this is a basically linear system of equation. So, from here I can get this is the system I will get a, b, c. So, if I get the a, b, c, then this value will be 1, 1, 1 here, because the first equation was a plus b plus c, that is equal to 2h. Then the next one was minus h, 0, and that was h, and that was equal to 0. And the last one is, I call it h square, 0, and this is also h square, because this is h square and h square, a h square plus c h square, that is equal to 2 h cube by 3. So, this is the equation number 5. So, this is a system of equation like a x is equal to b, and we know that we can solve it using maybe Gauss elimination method. And then we can find out the solution. So, if we solve this one using the Gauss elimination or any method we have discussed, then from here I will get the value of a and c, that is coming h by 3, and b is coming 4h by 3. So, that is the value we got. So, if we calculate this value, then after calculating this value, my integral will be equal to, so this is a is h by 3. So, this will be h by 3, then f of minus h plus b is this one. So, it is 4h by 3 f of 0 plus h by 3 f of h. And if I take the h by 3 common, so this will be h by 3 f of minus h plus 4 times f of 0 plus f of h. And if you see from here, then this is coming same as Simpson 1/3 rule. So, this is coming same as the Simpson 1/3 rule, because in that case also we have the value of the function at 3 points and we are able to find. So, this is similar as the Simpson 1/3 rule. Now, the error we want to find. So, error will be from minus h to h. So, this is because it is coming similar to Simpson 1/3 rule. So, I know that the error will be x plus h into x, x minus h, third derivative of this one by 3 factorial. So, that is 6 into dx. Now, if I remember from Simpson 1/3 rule, then I know that this value is going to be 0, because we know that the Simpson 1/3 rule is also giving exact results for the cubic polynomial. So, this will be equal to 0. So, in that case we have to take the error will be from minus h to h, x plus h into x square, then we can take into x minus h and the fourth derivative by 24 dx. So, this one we can calculate, and now how we can calculate this one. So, there is a first thing is that we can do the integration and we are able to find the result. The other one we can do is that we can find that the error will be, of course, it will be some c fourth derivative divided by 24. So, this c I want to find. So, this c we can find because I know that this is giving me the exact result for up to cubic. So, if I do the take the function x raised to power 4 dx. So, it is not a cubic, it is a fourth polynomial, 4 degree polynomial. So, I know that then I can find the error. So, this will be the difference between the value of a f minus h plus b of f0 plus c of f h, the formula, and I know the value of a, b, c. So, from here I can write that this is equal to minus h to h x4 dx minus h by 3. So, this will be equal to f minus h will be h raised to power 4, f0 will be 0, fh will be h raised to power 4. So, from here this will be x5 by 5 factorial from minus h to h minus. So, this will be 2 times this one. So, I can write a 2 by 3 h raised to power 5, this is also h raised to power 5, and from here I can write that this will be equal to 2 h5 by 5, because I can take h raised to power 5 plus h raised to power 5, 2 times h raised to power 5 minus 2 by 3 h raised to power 5. So, this will be equal to, I can take 2 h5 common, this is 1 by 5, 1 minus 1 3, the LCM will be 15. So, from here this will be coming minus 1 by 90 into h raised to power 5. So, minus 4 h5 by 15. So, this I am getting. So, from here my error will be, so c is this one. So, it is minus 4 by 15 h raised to power 5 fourth derivative by 24. So, from here this 4 will cancel out 6. So, I can write that this is equal to h raised to power 5 into 90. So, that is the error, and it is same as the Simpson 1/3 rule. So, in this case we have alternatively we found the error by taking the difference, and then we are able to find the error that is same as the Simpson 1/3 rule. So, this is the example we have solved. We can similarly we can define the another example. So, let us take the another example, example number 2. I have the integration from minus 1 to 1 fx dx. So, that is given to me is equal to, suppose some lambda 0 f0 plus lambda 1 f1 plus lambda 2 f2. So, this is given to me. Now, from here this is my minus 1 and this is 1, and my function is defined like this one, and I want to find this integration. So, this value I have. Now, in this case I do not know that I should choose this nodal values somewhere or I should choose any other nodal value, because the nodal value is also not defined. So, in this case this is basically equal to lambda naught f at x naught plus lambda 1 f at x 1 plus lambda 2 f at x 2. So, here we do not know the values of x 0, x 1 and x 2. So, in this case we do not know the value of the nodal points. So, once we are able to find the nodal values, then this methods will give you the same result as a Newton-Cotes method, but in this case we do not know the value of this x 0, x 1, x 2. So, that is why, so this is basically, if you see, this is a Gauss example of a Gauss Legendre's integration method. So, in this case I have 6 values we have to find out. So, we need to find values of x 0, x 1, x 2 and the coefficient lambda 0, lambda 1 and lambda 2. So, 6 coefficient we need to find. So, we will assume that the method gives exact results for polynomial of degree less than equal to 5. So, that we will consider. So, in this case let us take that for, so my r will be, in this case it will be f x I can take as x raised to power r and r can be 0, 1, 2 up to 5. So, for r is equal to 0. So, if I take r is equal to 0, then it is the constant. So, from here I can write that this will become minus 1 to 1, f x will be 1. So, this will be just a function minus 1 to 1 and dx, and that value will be 2. And on the right hand side I will get, so it is a 1, so it will be lambda naught plus lambda 1 plus lambda 2. So, that is my first equation I will get. So, this is the equation I am going to get. Then for r is equal to 1, I will get minus 1 to 1 x dx, and this is the odd function. So, its value coming 0. So, in this case, so this will be equal to lambda naught into x naught plus lambda 1 into x 1 plus lambda 2 into x 2. So, that is my another equation, third equation. Then for r is equal to 2. So, it is from minus 1 to 1 x square dx. So, this will be x cube by 3 minus 1 and 1. So, this will be equal to 2 by 3. So, 2 by 3, that should be equal to lambda naught x naught square plus lambda 1 x 1 square plus lambda 2 x 2 square. So, this is the another equation we are going to get. So, this is my equation number 4. Similarly, we can define for r is equal to 3, this will be minus 1 to 1 x cube dx, and this is the odd function. So, value will be 0. So, this will be equal to lambda naught x naught cube plus lambda 1 x 1 cube plus lambda 2 x 2 cube. So, this is equation number 5. This is 4, this is 5. then for r is equal to 4, this will be minus 1 to 1 x 4 dx. Now, if I take this value, so this will be 2 by 5. So, that is equal to lambda naught x naught 4 plus lambda 1 x 1 4 plus lambda 2 x 2 4. So, this is the equation number 6. And the last one for lambda r is equal to 5, this is minus 1 to 1 x raised to power 5 dx, this is an odd function. So, its value will be 0 is equal to lambda 0 x naught 5 plus lambda 1 x 1 5 plus lambda 2 x 2 5. So, that is the last equation, this is the 7th one. Now, from here we have this equation first, second, third, fourth, fifth, sixth. So, we have 6 equation. We have 6 equations and 6 unknowns. So, the unknowns I can take as a lambda 0, lambda 1, lambda 2, x 0, x 1, x 2. So, this is my the vector with the 6 value. So, we have 6 equation and 6 unknown which can be solved using Gauss elimination or other iterative methods, because Gauss elimination is a direct method, it is not iterative method. Using Gauss elimination or iterative methods, not others, or iterative methods. So, this one we can do with the way we solve the system of equation, and suppose, so we solve, if we solve this one, then the answer we are getting, that we are getting x naught is minus 3 by 5 under root, x 1 I am getting 0 and x 2 is 3 by 5 under the root. The value of lambda naught we are getting 5 by 9, lambda 1 we are getting 8 by 9 and lambda 2 we are getting 5 by 9. So, from here we are able to find the value of all the 6 coefficients or the unknowns. So, from here I can write that this is equal to minus 1 to 1 f x dx. So, this is equal to 5 by 9 f at minus 3 by 5 under the root plus 8 by 9 into the value of the function at 0 plus 5 by 9, this one, and this under root 3 by 5 is lying between minus and 1. So, that is the Gauss-Legendre integration formula for this function. So, using this one we are able to find that what is the nodal values, because nodal values are not fixed in this case, and then the corresponding coefficient we are able to find. So, that is the way we can find out that how the nodal value can also be chosen with. So, this is the way we can define the method of undetermined coefficients. So, from here if I want to find the error, then the error associated with this one, because from here I am able to find that this method is giving exact result up to the polynomial of degree 5. So, the error term in this case will be what? So, this will be equal to C f, of course, it will be 6th derivative by 6 factorial, where this xi will lie between minus 1 to 1, that I know. So, this c I want to find. So, c will be what? So, it is from minus 1 to 1 x raised to power 6 dx minus this one 5 by 9 f of minus plus 8 by 9 f of 0 plus 5 by 9 f of 3 by 5 under the root. So, from here I can find the value of c. Now, it will be x7. So, it is x7. So, it will be 2 by 7, right, because x7 by 7 and there will be 2 minus 5 by 9. So, this value will be minus 3 by 5 under the root. So, this will be equal to minus 3 by 5 under the root power 6 plus 0. So, it will be 0 plus 5 by 9, and this will be 3 by 5 under the root power 6. So, this one we want to calculate, and if I do the calculation for this one, this is coming equal to 8 by 175. So, from here I can say that the error corresponding to this will be 8 by 175 into the sixth derivative. So, I can write like this also, by 6 factorial, where xi lies between minus 1 and 1. So, that will be the error in this case. So, this is giving me the exact result up to the 5th degree polynomial, and that is the error introduced. So, this is the way we can find the errors and the method of undetermined coefficient. So, let me stop here today. So, today we have discussed that how we can apply the method of undetermined coefficients to find out the nodal value as well as the coefficients of that one. And we also found that how the errors can be found out with the alternative methods. So, that brings that the end of this numerical integration. In the next lecture, we will go for the MATLAB codes, that how the MATLAB codes can be made for the methods we have studied in the numerical integration. So, thanks for watching. Thanks very much.